Hey, who are you, man?
Hey, you don't know me.
I don't know you.
I'm actually Linux. I'm taken from Unix standards.
So what?
Oh, you don't know one more thing. I'm from Unix.works in 1991 only. I've established.
1991.
Yeah,
Good to hear.
yeah. Then you know one thing. I can do multitasking and I can perform in multiple platforms also.
Is it?
Yeah,
Sounds good.
yeah. And kernel and system are part of mine.
Hey,
Okay.
Okay, then I have some general public license and BSc license also.
General public license.
Yeah.
You are?
I'm free software.
Boss, you are really great.
Yeah, I'm great. I know that. And who are you?
hey boss, don't you know me?
I don't know you.
Shit, I'm the original piece of the software. Yeah.
Then?
I'll introduce myself.
Okay, please.
Okay. So, my very first question was 0.01. Since I didn't have any networking models, I was not that famous. Then slowly, when I got
Take it.
TCP and IP networking models, I was upgraded to 1.0 version. Slowly, when I improved to memory management and I got some improvement in performance also, then I improved to 2.0 version and finally my version is 5.7.
Hey, wait, I also have to say something.
Yeah, continue.
I am system. I was not fully developed from scratch, but I was taken some part of code was taken from development projects like GNU projects and tools of BSD operating system.
Okay. Guys, do you know about Linux design? Yeah, now I will tell you. I can do, as I told, I can do multitasking and I can work in different multiple platforms also. And you know one more thing? This Windows is there, no? He's my friend. But I can do work more than him. I'm speeder than him. Then, you want to know about kernel also? What's the design? No. Guys, have some jokes. Kernel, please go on.
So I have some hardware resources. I do have different modules which performs only specific tasks.
I have two parts: system utilities and system libraries. I have set of functions which are used by apps to connect with the kernel. And I can do a specific task.
Okay. Kernel, you got about your modules. Can you explain about this?
Yeah, definitely.
Yeah, please do it.
So I have modules which support three different properties. The very first one is module management. In module management, basically we load the data into the memory. As you all are familiar with MC Lab, you just load the values of the data into the registers, right? Yes or no? Yes or no? So you didn't attend MC Lab? So if you attended, you will be knowing. So similarly, we load the data into the memory. And then the second one is driver registration. In driver registration, when new devices get connected to me, I automatically know. So now, these are the devices which got connected to me right now. So I got to know that they are the devices which connected to me. So that is called driver registration. And the third one is conflict resolution mechanism. In this, we have different modules which fight for hardware access of the resources.
Then we will see about Linux process management.
I'm the parent process.
And I am the chain process. So as a chain process, I have two system calls. The first one is fork and the second one is execute. As you all are familiar about the fork system call, it is a system call which is used to create a tree. And the second one is execute. Execute system call is used to run a new program. And then I have different properties. Are you guys interested to know what all the properties are?
No.
Interested to know also I will introduce it. So my properties are the following.
Hi, I have process identity. I have some unique identity number, and I will maintain the credentials of the resources, and I will store the current information.
I am this environment. I am inherited from my parents, and I have two components that are. One is environment, and another is intra. Thank you.
Hi, I am the process context. My main job is to schedule the context. I will create, I maintain the handling, creation and the deletion of a file. I maintain the virtual memory context, that is to put the private address space.
Then now we will see about process scheduling in Linux. Basically, in Linux, process are known as tasks. But in Windows we will call it as a process, but in Linux we will be calling it as task. So it will happen in two ways, like in priority and time slice. When priority is from 0 to 99, it will happen in real time task with time quantum 200 milliseconds, and other task will be with priority 100 to 140, which will happen in time quantum 10 milliseconds. I think this is enough. Now we will see about memory management. Memory management means allocating the memory for each process with the need of the OS. Then we have two types of physical memory. Memory, that is physical memory and virtual memory. Physical memory we will see.
I'm the physical memory. If I really want something, very short, less than 8 MB of size, I can give it directly from here. That is the direct memory access. If you really want something big, it's a normal one, up to 896 MB, I can give it from here, okay? And if you want still more than that, I have something in the back store. That's what I call the high memory. It will take some time, but I can store more. This is about the physical memory.
Hi, I am virtual memory. My main role is to store this address space used by processes. So I have two views. First is logical view, and the another is physical view. In physical view, the information are stored in hardware like pages, and it may overlap. That can be overlap. But in logical view, the address space is stored in different regions, so it can't overlap. And in virtual memory, we use next fit. That means first, when address space is being searched, that will start from first. But when it is called next time, it will start from where it was left off. It won't start from beginning.
Now we saw memory management. Now we will be seeing about file system management. In Linux file system management, where du command is used to see that which disk or which driver is connected to the OS, that will be used by the command du. If you want to like free the memory or free the disk, then you need to use the command df. If you want to see that memory in KBs or MBs, you can use with KB, like -k and -m. If you include it with commands, you can do it. And if you want to insert any drivers like pen drive or any other devices, first you need to mount in Linux. So for mounting, you need to use syntax like the device name and syntax. Sorry guys. In syntax, first we need to use mount, source file, and then destination file. For unmounting also, you can't remove the device like connecting. You need to use syntax like unmount, source file, and then destination file. Then we will be seeing about input-output operations happening in Linux. Input-output operations have been mainly classified into three types. One is block devices. In block devices, we will be seeing about floppy disk, which can be accessed randomly. And in network devices, example is Ethernet, where you don't have direct connection for accessing the data. You will be having indirect access to the data. Then now we will be seeing about inter-process communication.
I'm the process 1.
And process 2.
We are two separate processes, but we share data among ourselves.
Actually, they are like friends. They will share data in 4 different ways. First one is pipe mechanism.
Hey, I'm sharing the data.
I'm receiving the data.
Yeah, here in two process they will share data and one will receive it, and it happens. It is called as pipe mechanism. In second mechanism we called it as shared memory, where we have one resource, both will access this resource. It is called as shared memory. Then third one we have called as synchronization. Synchronization, where both should be in sync. Now he is not in sync, so he didn't receive the data. Then again the process acknowledges that he is sending the data.
Hey, I'm sharing the data. Be in sync.
So he will be in sync and takes the data. Then we will be. The last mechanism is network interface, where those two are in one system and me and sir are in another system. If we want any data to be accessed from that system, we will be accessing. Like I need some data.
Hey, I'm giving it.
Yeah, I got some data.
This can be shared between the processes in this system.
Yeah. Yeah, that's all, guys. Sorry for interrupting. We are the team. We played this role. Actually, everyone played well. Sir also helped us very much in doing this in a short span of time.
I think it was actually scripted by Anjali and Manoj together. They have, I have just given the PPT and the content. They are the writers behind it, and they are the actors. I just filled the role that it was supposed to be played by someone else. They were in leave today, so I just played some roles in that. So once again,